And this guy right here, you want to hold him the right way. And this is one, it's actually easier to hold. You want to hold it so you see a triangle in the middle and so you have an up and down axis. That's how you want to hold it. To do this with your pins, you're going to take your triangle shape that you drew your circles on. You're just going to take one pin, poke it halfway through it, and now you have that shape. You have an axis up and down, and then you have your triangle parts right there, there, and there. That's really easy to see. Now there's a rule to how you can take off the lone pairs, how you can take off the atoms and replace them with lone pairs. Right here, you have to do it on the triangle. They call it equatorial. You have to do it on the triangle. Notice that we do still have a 180-degree angle, and our triangle had the 120s. I'm going to take him off. So that's kind of like what I usually tell people is just kind of roll this side up and pretend it's not there. You see, I still have part of a triangle. You can see I kind of have part of a triangle. And this one, you set it down like this. So with your two little lines, set them down like that. Set them on as little lines. And then you have a seesaw. Really is the name, seesaw. You take that and you go up, down, up, down, up, down. Now, again, you have to keep taking off the equatorials. What letter does that look like if you turn it this way? It's a T shape. And if you roll in this atom, so you pretend this paper isn't here, all you have is just this one circle. You can see that this makes for a T shape. It goes out the side there. And there's your vertical. If you lose that last atom, you're stuck with being linear, with something in the middle. If I lose that last atom, linear. All right, and so to make this one, you want it to have a vertical axis just like the last one. So give it a vertical axis. You want to, again, take your pen, put it halfway through. So these are the atoms on the outside of that rectangle. And then the top of the pin's an atom and the bottom of the pin's an atom. You at least kind of see the shape of it. So in this case, you want to take the atoms off the axial. Start at the bottom so it's easier to see. Now that's a lone pair. Electrons moving really fast, little tiny electrons. Now we have a pyramid. So it's like covering up the bottom of the pin. Pretend it doesn't exist. So we have a pyramid with a square base. You can imagine the edges coming up to the top on the pyramid. Take off the other one. So it's like saying, take the pin out. That's still an atom in the middle. It's flat, just like that other planar one, but this one's a square, not a triangle, so square planar. Take off another one, all of a sudden, we have that T shape again. So it's like kind of folding up one. And if you connect the lines, you got a T shape. And then if you take off one more, you're bent, but this bent only has a 90-degree angle. That's how you take your electron geometries and you turn them into molecular geometries.
Before you